In section R5, we're going to be talking about what are called rational expressions. Now, if you recall what we talked about with rational numbers were numbers that could be written as a fraction, or they terminate, or they repeat. So typically when we're talking about rational numbers, we use the example 1/3. Now, a rational expression has x in it, but generally you have like a numerator function and you have a denominator function. All right, so a rational expression could look something like that. A good example would look like maybe x plus 1 over x minus 1. So you have a fraction, but the fraction does have variables in it. So let's take a look at what we need to know about rational expressions. First thing we need to know is we need to be able to find the domain of a rational expression. Now, what domain means possible values of x that we could use. So that brings up the question, well, what values of x can't you use, right? So you're not allowed to have a denominator equal to 0. Okay? So we're not allowed to have the denominator equal to 0. So what we could do is let's figure out what values make the denominator equal to 0 and just say don't use those numbers. So if we take a look at an example like this, say we have 3x minus 1 times x plus 1 over x plus 2 times x minus 5. Now the question would be to state the domain. Well, when we were talking about the domain, at least for a rational function or a rational expression, we said that the denominator is not allowed to equal 0, right? So we don't care about the top. The top has nothing to do with anything. We can't have x plus 2 times x minus 5 equal to 0. That would be a problem for us. So what values make that happen? Well, when x plus 2 is 0, or when x is negative 2, or when x minus 5 is 0, or when x is 5. Those two numbers would cause our denominator to be 0. So when we're stating the domain, we state the domain in set notation. Set notation has, they're called curly brackets, and we say that the domain would be any x value such that x does not equal negative 2 or 5. So it's a different kind of notation, but this symbol means such that. So if we were to read this, it would be x values such that x isn't equal to negative 2 or 5. So you make your denominator equal to 0, and you figure out what numbers make that happen and omit them from the domain. Next, I would like to talk about how to write rational expressions in lowest terms. And when we're talking about writing in lowest terms, what would you do if I asked you to write 8 divided by 2 in lowest terms? 8 over 2 is 4, right? Really what we're doing is we're simplifying, or we are factoring and cancel our common factors. One thing that is important to realize is that factoring is the most important thing in all of math that you'll ever learn. Factoring is the most important thing. So in the last section that we talked about, section R3, I posted supplemental material on factoring if you need help with that. You should have learned that in your last math class, but if you need additional practice, we talk about it in that supplemental material, and I'll bring it up also when we're doing this section. So when we write in lowest terms, let's take a look at some examples. How about 2x plus 8 divided by 2? Well, when we're factoring, generally there's 4 different ways that we factor. One way to factor is we take out what's called the greatest common factor. So if you look at the numerator, we could actually take out a 2 from the whole top, and we have x plus 4. Factor means to write as a product, and that's exactly what we just did. We said 2x plus 8 is the same thing as 2 times x plus 4. We could see that these factors are the same. Whenever you multiply and divide by the same thing, they cancel. So your answer for this problem would just be x plus 4. How about a problem like this? Let's say 2x squared plus 7x minus 4 divided by 5x squared plus 20x. And when we're factoring, I told you that there's 4 types. First type is GCF. So I'm looking at this problem. There's no common factor in the numerator. So I'm going to leave that alone. But in my denominator, I could actually take out a 5x. And we're left with x plus 4. The second type of factoring that we could do is called grouping. Grouping we use if there's an even number of terms, like 4 terms. We cut it down the middle and we take out a GCF. I'll go over that a little bit later on. Third type of factoring is called trinomial factoring. Some teachers call it the AC method, which I'm going to show you here. And then the fourth type of factoring is called special cases. Everyone hates special cases, but that's like if you have a difference of squares or a difference of cubes or a sum of perfect cubes. But we'll be going over those in a little bit. So we still have to factor the top. So I'm going to take 2x squared plus 7x minus 4, and I'm going to do what's called trinomial factoring. Now, everyone's coming from a different background, but one of the ways that I found to factor from my years of experience that most people understand is called the AC method. So what we want to do is we want to multiply 2 times negative 4. It's called the AC method because we could write this like a quadratic equation, ax squared plus bx plus c. AC would be 2 times negative 4, and then the b term goes on top. What we want to do to factor this is we want to find 2 numbers that multiply to give us AC, or negative 8, but the same 2 numbers, we want to add them so that we get the middle term, b. So that's the tricky part of finding those 2 numbers. Well, if we use positive 8 and negative 1, we get exactly what we want. Multiplied, we get negative 8. Added together, we get 7. So those are our numbers, 8 and negative 1. So in order to factor this trinomial, what we're going to do next is break up the middle term. Instead of saying 7x, I'm going to write 8x and minus 1x. I'm just changing the way that this looks. 7x is really the same thing as 8x minus 1x, but by doing it this way, we could actually cut it down the middle. This is called grouping. We could take out a GCF from each half. So between 2x squared and 8x, we could take out a 2x, and we're left with x plus 4. Between negative 1x and negative 4, we could take out a negative 1. If the leading term's negative, you always want to factor out a negative term. And now again, looking, it looks like we have a GCF of x plus 4. So we'd write x plus 4 times 2x minus 1. All of that is what the numerator factors to. So we have x plus 4 times 2x minus 1 over 5x times x plus 4. Well, you could clearly see that these cancel. Those are the same. Whenever you're multiplying and dividing by the same thing, those cancel out. And our answer would just be 2x minus 1 over 5x. Let's do one more. C. It has x squared minus 2x plus 1 over x squared minus 1. All right, so I see no GCF in the numerator or denominator, but in the numerator that is a trinomial. So I'm going to do the same AC method that we talked about before. Multiplying 1 times 1 gives us 1. have to add up to be -2. So -1 and -1 would get the job done. So I could factor this to be x squared minus 1x plus 1. Cutting it down the middle, I could take out an x. I could take out a -1 here. And you know that you did this right if you get the same thing in parentheses. So the numerator factors to be x minus 1 times x minus 1. And the denominator? Well, I'm looking at the denominator and I see a perfect square. That was our fourth technique for factoring. Now the formula for a special case, if you have squared terms, is it's a plus b times a minus b, where a is the first term that's being squared and b is the second term that's being squared. You should know your trinomial formula too. The formula is a minus b times a squared plus ab plus b squared. And then this one would be that for the sum, a plus b times a squared minus ab plus b squared. Generally, I tell my students to remember SOAP. That tells you how to figure out what the signs are for the cubic factoring. S stands for the same sign. So like you can see, this is plus, so this is plus, minus, and minus. O stands for opposite. And AP stands for always positive. We'll talk about this more later. So as far as the special case, x squared minus 1, this is really the same thing as x squared minus 1 squared, where a is x and b is 1. So using special case factoring, this would be x plus 1 times x minus 1. You can see we have the same factor in the numerator and denominator. So if we cancel those out, we get x minus 1 over x plus 1. A couple more things to talk about here. Next, we're going to be explaining how to multiply and divide rational expressions. In the first case, we have 2y squared over 9 times 27 over 8y to the 5th. Now generally what we could do is we could cross reduce, like between 9 and 27 we could do that, but there's a few different ways we could do this. One thing we could do is we could just multiply fractions, and we do that by going straight across. 27 times 2 is 54y to the 2nd, 9 times 8 is 72, y to the 5th, and then this would be like an example we saw in a previous section. 54 over 72, if we cancel out common factors, that reduces to just 3/4. We can keep dividing by 2 if you want. I actually think 9 would go into 54. We could just keep reducing that way. And y to the 2nd divided by y to the 5th is y to the -3rd. Remember, we subtract. So our final answer for this, we would bring the y to the denominator, would be 3 over 4y to the 3rd. That would be the way I would do this. Some people might reduce this by saying 9 goes into 27 3 times, 2 goes into 8 4 times, so you can see we have the 3/4, and then y to the 2nd goes into y to the 5th 3 times. So you wind up with 3 over 4y to the 3rd. If you weren't really taught that, this way I think is the way to go. What about if we had a problem like this? 3p to the 2nd plus 11p minus 4 divided by 24p to the 3rd minus 8p squared divided by 9p plus 36 over 24p to the 4th minus 36p p to the third. Now what we're going to do first is we always want to factor, and when we're factoring we go down our 4 steps. First thing we look to do is take out a GCF. There's nothing to take out for the upper left, but we could take out an 8p squared, and we're left with 3p minus 1. We're dividing. We could take out a 9, and we have p plus 4 over, let's see, between 24 and 36, we could take out a 12p to the third, and we would be left with 2p minus 3. So that's our first step with factoring. Second step is we looked at grouping. Grouping would be if we have 4 terms, like we had talked about that right here. This is grouping because there's 4 terms. We don't have 4 terms anywhere, but we do have a trinomial. So I'm going to use the AC factoring technique to factor that. 3 times negative 4 is negative 12. But they have to add up to 11. So I'm going to use 12 and negative 1. So we get 3p squared plus 12p minus 1p minus 4. Cutting it down the middle, we could take out a 3p. And completely factored, this would be p plus 4 times 3p minus 1. So we would get p plus 4 times 3p minus 1 divided by ap to the second times 3p minus 1. But you could see we're dividing by a fraction. So sometimes people say keep, change, flip. When you divide by a fraction, like 2 divided by 1/3, that's the same thing as keep, change, flip, multiplying by the reciprocal. So just flip the fraction and turn it into multiplication. So let's see what we actually get here. If we multiply straight across, we get 12p to the third times p plus 4 times 3p minus 1 times 2p minus 3 over 8 times 9 is 72. P to the second times 3p minus 1 times p plus 4. So this is like a little bit more enjoyable. We can cancel out our common factors. And then we have 12 over 72, and that reduces, let's see, we could, 4, I think 4 goes into them. You can keep dividing by 2, but eventually this will just be 1/6. And then we see we have p to the third divided by p to the second. So if we subtract those, we get p to the first. And on top, we're just left with 2p minus 3. That would be how you reduce something like that. So it's a longer problem, but it's not that bad. Try one more. If we had a problem like this. I think I'm numbering them like this. Yep. So C, we have x to the third minus y to the third. So that's a perfect cube trinomial, the difference of perfect cubics. We have a difference of perfect squares, x squared minus y squared, times 2x plus 2y plus xz plus yz over 2x squared plus 2y squared plus zx squared plus zy squared. All right, so let's get to factoring. I don't see any kind of GCF in any of these. Second step I move to is grouping. So I do have 4 terms here and here, so I'll cut those down the middle and factor those. I can take out a 2 and I get x plus y. I could take out a z and I get x plus y. So I just get 2 plus z and then the x plus y. That would be the upper right. Let's do the bottom right. 2x squared plus 2y squared plus zx squared plus zy squared. Cut it down the middle. We could take out a 2. take out a z, and we'd get x squared plus y squared times 2 plus z. Okay, so we factored the right fraction. Now on the left, we have x to the third minus y to the third, which is a difference of perfect cubes. So according to the formula, we're going to write this. Remember, go back to our formula for cubics right here. Whatever you're cubing, that turns into A, and the second one turns into B. So we're actually looking at these two formulas right here. So I'd write those down and commit those to memory. The way we factor x to the third minus y to the third is we use x, same sign y, x squared opposite, always positive. That would be how that factors. And then the denominator is a difference of perfect squares. So x is A, y is B, so we're going to say x plus y times x minus y. So when it's all said and done, let's write what we have here, and then we could cancel out our common factors. We get x minus y times x squared plus xy plus y squared over x minus, let's see, yeah, that was the difference of perfect cubes. The difference of perfect squares would be x plus y times x minus y. Using the grouping, the upper right was 2 plus z times x plus y over x squared plus y squared times 2 plus z. All right, so now let's cancel out our common factors. You can combine all these if you want, but just leave them separate. This cancels with this, x plus y cancels with x plus y, 2 plus z and 2 plus z. It looks like all we're left with is x squared plus xy plus y squared over x squared plus y squared. That would be the answer. It's a little bit longer, but that's it. To finish this section, let's talk about how to add and subtract rational expressions. So let's start off with an easy problem. So let's just say we had 1/2 plus 1/3. We learned in middle school that we need a common denominator. So to combine these fractions, we look to see what would your least common denominator be. And most people would say 6. 6 factors to be 2 times 3. We need a factor of 2 and a factor of 3 in each denominator. So whatever you're missing, we multiply the top and bottom of that fraction by it. And we get 3/6 plus 2/6 gives us 5/6. All right, so let's get a little bit more advanced here. What if we had a problem like 5 over 9x squared plus 6 over x? So our LCD means we have to have the same factors in the denominator of both fractions. Well, between 9 and 1, common denominator would be 9. And between x squared and x, we have to make them both into x squared is really x times x, right? So we would need a factor of x and a factor of x. So this one's missing an x over here. The LCD would be 9x squared. All of our denominators need to have that. All right, so it looks like this first one has it, but we need to multiply by what we're missing in the second one. So we get 5 over 9x squared plus 9 times 6 is 54x over 9x squared, just giving us the top 5 plus 54x over 9x squared. That's how we combine those two with the least common denominator. What about a problem like this? This is kind of interesting. We have y over y minus 2 plus 8 over 2 minus y. Now y minus 2 and 2 minus y are pretty close, right? It's like, what if y was 5? 5 minus 2 is pretty close to 2 minus 5, but it's off by a negative. So when you have something that's pretty close like this, what we're allowed to do is we could actually factor out a -1 So watch what I'm talking about. If we divide, factor is just another word for divide, 2 by -1, we get -2. Negative y divided by -1 is just positive y. And if we rearrange it, we get y over y minus 2 plus 8 over -1 times y minus 2. And it's easy now to see that our least common denominator would be -1 times y minus 2. So we would have to multiply this fraction by -1 over -1 in order to combine them. And then our final answer would be -y plus 8 over -1 times y minus 2. Now at this point, some people would factor out a -1 from the top and bottom. So if you divide everything on top by a -1, you would get y minus 8, and everything on the bottom by a -1 would be y minus 2. But you should just be able to recognize that these two forms are the same, and you should be able to understand how to get there. Okay, I have 3 more to finish up this section. What if we had something like this? 3 over x minus 1 times x plus 2 minus 1 over x plus 3 times x minus 4. Now, we have to get a common denominator, right? So every fraction is going to need an x plus 3. Every fraction is going to need an x minus 4. That's why it's called a common denominator, because every fraction has it. Every fraction is going to need an x minus 1 and an x plus 2. So we have a lot of multiplying to do here. Whatever that fraction is missing, you have to multiply the numerator and the denominator by it. So the one on the left, we would have to multiply by x plus 3 times x minus 4. Top and bottom. One on the right, we'd have to multiply by x minus 1 times x plus 2. Top and bottom. I think I said something. I said x minus 1. X minus 1 times x plus 2. Let's see what we get here. So we're going to have 3 times x plus 3 times x minus 4. They're going to have the same denominator, so we could just go ahead and combine them. And then we're going to have minus 1 times x minus 1 times x plus 2. So now let's multiply the top out. We're going to have to distribute here and here, and then we'll distribute the constant in front. This will just be x squared minus 4x plus 3x minus 12 minus 1 times x squared plus 2x minus x minus 2. Generally, what we do is we usually keep our denominators factored, because in the end we might have factors to cancel out. So just leave your denominator totally factored. I'm going to distribute the 3. Actually, this would be negative 1x, right? So 3 times x squared, and then 3 times negative 1x. And then we're going to have minus 1x squared. This would just be x, right? So negative 1 times x, and then plus 2. So let's see what this turns into. The x squareds are going to just give us 2x squared. The x's are going to be negative 4x, and then negative 34. We could actually factor out a GCF of 2 on top. And when it's all said and done, we always want to look to see if we could cancel anything. Now, factors of 17. 17 is a prime number, so we're all done. That would be what the final answer is. Okay. We have a couple more problems, and they're similar. So let's say we had 6 minus 5 over k divided by 1 plus 5 over k. Now there's a couple different ways we could do this. What we could do is we can combine the two top terms by getting a common denominator. We can combine the two denominators by getting a common denominator. One thing that I usually do is I just get rid of all the fractions. Watch what happens. It looks like if we multiply the top and bottom by k over k, it's really just 1, right? But watch what happens. If you multiply everything in the numerator by k, you would get 6k minus 5k over k. So this last part would be 5k over k, and the k's would cancel. So you're multiplying by k and dividing, so those cancel. Same thing with the denominator. If we do the same thing here, 1 times k is k, 5k over k is just 5. And that would be it. So you're going to have a question on the exam, and usually on the final it's similar to that. And that's pretty much as easy as it gets. Another way we could have done this is we could do 6 minus 5 over k over 1 plus 5 over k. You can get a common denominator on top and on the denominator. Common denominator on top would be k over k, right? And on the bottom would be k over k. So we could write this, the top 6k minus 5 over k divided by k plus 5 over k. Or 6k minus 5 over k divided by k plus 5 over k. We talked about when you divide by a fraction, that's the same thing as multiplying by the reciprocal. These would cancel, giving you the same exact answer we got before, which would be 6k minus 5 over k plus 5. So, I mean, there's a couple different techniques. You guys decide, which way is easier for you. One more example. What about if we had a problem like this? A over a plus 1 over a divided by 1 over a plus 1 over a plus 1. Well, we could do it using the first technique or the second technique. The numerator, the LCD, would be a times a plus 1. The denominator, LCD, would be the same exact thing. So if we multiply the top of our fraction by a plus 1 times a, and the denominator by a times a plus 1, we'd actually get rid of all the fractions. It's a little bit of a shortcut. You could get a common denominator. I'll show you that also, but let's see what we get here. I'm going to multiply a times a plus 1 times a over a plus 1 plus a times a plus 1 times 1 over a. Denominator, I'm going to multiply a times a plus 1 times 1 over a plus a times a plus 1 times 1 over a plus 1. When you multiply and divide by the same thing, they cancel. So we just get a times a plus a plus 1. And denominator, these cancel, giving us just a plus 1. And these cancel, giving us just a. So we wind up just getting a squared plus a plus 1 over 2a plus 1. That would be the answer. Okay, that's if we multiply top and bottom by the LCD. The other technique I just want to show you, you don't have to do it this other way, but I like showing multiple techniques, is by getting a common denominator and then multiplying by the reciprocal. So the same problem, a over a plus 1 over a divided by 1 over a plus 1 over a plus 1. Well, in the numerator, the LCD would be a times a plus 1, so you'd multiply by what you're missing. And the top would turn into a squared plus a plus 1 over our denominator. In our denominator, we'd multiply by what we're missing to get our common denominator. And we'd get a plus 1 plus a divided by our common denominator. And we have a fraction over a fraction. Let's write it out horizontally. And then we're going to multiply by the reciprocal to finish this up. And you should start seeing what's happening, right? These are going to cancel. We wind up with the same answer we got over here. All right. Thanks for following along. Stay tuned for the next lesson.